to an important element of the smart metering puzzle, should I say, at the moment. Because this is an area where it is not only very controversial, but everybody seems to have an opinion. But it is important we bring these to the table so that the people who are actually implementing projects understand what are the challenges, what are the technology options available, and what can give them the best results. We are fortunate that we today have very senior people from the industry who've been through these situations before and can share with us their experiences on what they think are the options on technologies, what are the criteria where we should be talking about selection. There are issues about meeting SLAs, meeting the stated and unstated security requirements, and the way we see this very complex environment moving forward. Because today we are talking of just meters, but even within meters, we have to go beyond electricity. There is gas, water. There are other grid devices. There are EVs coming. There are street light controls. There are smart grid applications that have to be connected to devices in the field. So how do we make sure that what we are building today is not just for the smart metering that we are trying to implement today, but for the next 5 to 10 years, that infrastructure is more useful and we don't have to redo it again. Okay? So I'll just throw open the field again, and let's start with you, Fabien. Can you share with us your opening thoughts on some of the issues we have been talking about?
Sure.
Thank you.
Thank you. Sure. So maybe I'll start by just introducing ourselves. So I'm CDO at Ubiik. So it's a Taiwan-based company, and we are indeed wireless communication experts, and we are also a AMI vendor in Taiwan. We are the largest AMI provider in Taiwan, where we deploy a private network essentially for Taiwan Power, which is obviously the sole energy provider in Taiwan, so it's a much simpler landscape than India. So in that context, we've been using LPWAN. So we are using a LPWAN type of technology, which is called weightless. It's a open standard technology that we have been implementing on operating on a license band, which in the specific case of Taiwan, actually, there are options to use unlicensed bands, like the 865 XTT8 of India. In Taiwan is 923 to 925. You have option to use cellular technologies as well. LTE-M and NB-IoT are both deployed in the country. And you add actually the option as well to use dedicated band for public utilities. So the NCC, which is a regulator in Taiwan, did set aside 8 megahertz of spectrum dedicated to public utilities. Now the requirement didn't call for AMI provider to necessarily use that band. You could be using unlicensed band or cellular technologies as long as you meet the technical requirements, which are based on SLA, delivery, 95-96% of the load profile, 15 minutes, being able to do reading over the air, firmware update over the air, etc. And as long as it delivers security as well, which for the end-to-end security is guaranteed by the LMS protocol, but then also requires some security on the link itself. So we have experience deploying 1.2 million meters using weightless for 92% of the deployment, and cellular technology for the complement, be it LTE-M or NB-IoT, and a little bit of Cat1. So we have experience in bringing all those technology back to the same head-end system, which we're also responsible for providing, as the model in Taiwan was a tendering process for the meter itself, which is a smart meter, but which is not communicating. So it doesn't have a communication module. Then there was a tendering process for the communication infrastructure, going from the NIC, which is called a FAN, but the NIC, the DCUs if you need some, so for weightless we do need some, and the head-end system, and then providing the data to the MDM. And then there was a tendering process for the MDM itself. So the different communication infrastructure vendors will push to the MDM and provide that data as a service. So with similarities to the MISP principle used in India, except it's limited to the communication infrastructure from the NIC to the head-end system pushing to the MDM. But we are also operating and servicing that network for Taiwan Power. So as of today, with more than 2,000 base stations or DCUs deployed. We think that the model in India is very comparable. So we want to bring our experience and lesson learned from Taiwan as well to potentially provide RF communication technologies for the Indian market, where we also think that actually we will need a combination of technologies, be it LPWAN like wireless, mesh technologies when that's useful, or cellular connectivity. We think that the scale of the deployment is such that to deliver the SLA and to deliver that data to the DISCOM, you will need to have a mix of technologies no matter what, and no matter how good are the technologies. And we are here to provide technologies like that, and also to open up a little bit the discussion on aspects that, in the tendering so far for the Indian AMI, we've seen you could use cellular technologies, PLC, although it seems to be a little bit out of fashion, and unlicensed band. But in the unlicensed band right now, it's actually calling for RF mesh technologies, kind of as a mandate to use RF mesh. We want to open up the discussion here a little bit and look at what has been done around the world for AMI, which has been deployed in unlicensed band almost in every major countries in the world as a combination with cellular in many cases. And open up the discussion on the fact that using unlicensed and licensed band and using RF mesh or cellular type of technology like narrowband IoT are separate discussions. So in essence, we are also showing that we are using a LPWAN technology, wireless, in a licensed band in Taiwan. So we do pay a license fee for every DCU we install, but we don't pay the amount that operators will pay for their high-value services on the spectrum that they actually had to bid very high amount for, and which we believe cannot sustain electricity AMI demand. Equally, actually, you can enable technologies like LTE or NB-IoT in unlicensed spectrum, and those are things that we are actually seeing happening in some other regions of the world. And we think that over the course of the deployments that is going to happen in India and the years to come where it's going to be deployed, even though a large chunk might be done by 2025, we think that opportunities should be given to have more technological choices for the communication technology. And we are here to provide the core technology and also the communication mix that could deliver the SLA, which at the end of the day is what matters.
Okay. Fabien, just one question I wanted to add to that is, of late, DOT has started a discussion, a consultation in India, saying private networks, especially using unlicensed bands, are weak on security as compared to, let's say, the shared communication services. What do you think is the role of shared versus private networks, and how do security elements get taken care of in either of them? I'm specifically asking you because you play in both the fields.
Yes, so on that aspect, I think my point of view is, well, there are two sides of it. Besides the practicality of changing that right now when deployments are occurring already, I think we can just look at over the world. AMI has been deployed a lot on unlicensed spectrum. The topic of security is always paramount, not just in India. And I would really liken that to the fact that unlicensed or licensed spectrum has nothing to do with security. So no matter the user of that spectrum pays for it or doesn't pay for it, doesn't change the fact that someone can tamper with that spectrum and try to listen what's over the air. It's not just because you call it a licensed spectrum that it is private and nobody can see what the spectrum is available to everybody to see. And the second aspect to it is, yeah, the technology. So you could compare the technologies deployed on unlicensed band and the technologies deployed on licensed band. So first, our point is actually you could deploy cellular technologies in unlicensed band and vice versa. If some spectrum was dedicated and licensable for technologies like weightless or like mesh, they could be deployed there as well. And second is, what's most important is when we talk about the communication technology, this is really the security of that communication technology is to protect the data over the air between your device, so between your meter and the collector, DCU, base station for operator, or access point DCU, whatever you call it. So you can liken that very much to Wi-Fi. When you connect to a Wi-Fi hotspot, you also use unlicensed band. That's another band at 2.4 gigahertz. The link between your device and the Wi-Fi hotspot is secured with AES 128, etc. And on that aspect, all technologies, cellular, RF mesh, weightless, you name it, follow the industry standard, or at least we need to make sure they do. But they are all following the same industry standard to do that, and exchange keys, etc. But anyway, the data that is collected by your device and goes all the way to the head-end system, this is following the DLMS protocol. And that's what guarantees the end-to-end security. So your meter reading, how many kilowatt I consume, this is actually carried into the DLMS protocol. So from the meter itself, it's encrypted all the way to the head-end system. So even you go over Wi-Fi or even over a plain unsecured wireless link, you will not be able to tamper with that reading because that's DLMS guaranteeing the end-to-end security. Just like your phone is doing Wi-Fi, the end-to-end security is guaranteed by SSL, TLS, those connections to the server. That's not because of the Wi-Fi password that you are protected. So I think it's important to, security is multi-layer, and what's the most important is still the end-to-end in terms of tampering with the data of the meter. And on that aspect, I think more could be done to guarantee the end-to-end security of the link. And it was mentioned in session before, things like key provisioning and how those keys of those DLMS meters are stored inside the meter in a secure way and are provisioned in the head-end system in a secure way. Those are actually, for the end-to-end security, more important matters than the actual security of the wireless link. So that's a comment I would make. And also just license band, unless there are dedicated band assigned for utilities where the license fee is, I would say, affordable and can sustain that use case, the license fees that operators have paid are for high-value services. So when they deploy NB-IoT, they can only give a very small slice of their spectrum because that's very expensive spectrum. So it cannot sustain electricity AMI deployment in terms of capacity and cost. We see that as a complementary solution. You know, there are places where it's not easy to install DCUs, etc., and then the public network has good coverage, then that's a great solution. Just go with that. But then if you have a large density or an urban setup, then you should fall back, I should say, to technologies that can do that at a lower cost using unlicensed band. Or utility dedicated bands where essentially the government kind of bear some of the cost of that service by providing licenses at a lower cost. So I think those are the comments, and we would like to see those discussions going forward happening in India, including the potential use of cellular technologies like LTM or NB-IoT in the unlicensed spectrum, or maybe in the upcoming 900 megahertz band in India, because those are very, very critical assets, and I think this could really be enablers for deploying AMI and making them work at scale, because nobody discusses the fact that it's going to be challenging in some regions or some geographies that were talked about earlier, mountainous with very, very low usage per user. How do you make that cost effective? Maybe you can't, but you know, we have ways to make it more efficient. So that's my take on it.
Thank you, Fabien. That's very, very informative. And the one thing we can be very certain of, the world we're living in today, we are going to have more and more attempts on cyber crimes, on people trying to break into the utility systems, and what else that can they control, if they are able to control 250 million establishments and able to switch them off, imagine the chaos that would lead to. And not just the chaos, it would be so bad that people will lose their lives in that process. And I guess the two important things, takeaways from there are, irrespective of the communication technology, irrespective of the licensed, unlicensed band we're talking about, the key to security is the end-to-end encryption and the fact how you manage the keys and the security certificates. Those two elements are the key to achieving the best security that we need. Yeah.
Sorry.
Yeah, please, please.
So on this
Ramana.
topic, right? So hi, I'm Ramana elchuri. I head the sales at Cyanconnode. So obviously we're all going through a litmus test about this DOT DOT memorandum. So I think I'll just take off from where my peer from the industry was talking about Wi-Fi, right? One analogy that I also want to again stress here is, I mean, in fact, I was talking to somebody in DOT, right? I mean, you have every office like a Ministry of Finance or a Ministry of, any ministry you talk about, right? They're obviously working on critical services, undoubtedly.
Yeah.
Right. But then you have Wi-Fi internally. Are you going to replace every Wi-Fi connection with a 4G? It's a basic question that I asked. Because see, criticality cannot be defined at one sector, right? Obviously, it's critical all across, right? So that's one analogy. And then talking about security, right? One thing we need to keep in mind is that the RF networks, right? It's not just that something is, kind of evolving in India or, we're trying it in India for the first time. It's a globally, adopted technology, right? In that sense that if I have my numbers correct, close to 100 billion meters across different programs like the UK National Smart Metering Program, they have implemented close to, across the world, right? I mean, they have different license-free band. One point is that, we keep raising the point that it is license-free, rather than they should say it is in a license exempt band, which is actually defined by CEA, right? So the point we're trying to make.
Globally for every country.
Exactly, globally defined for every country.
India providing this is globally available in every country.
Every country, and one more specific example I would like to point out is that Japan, where they've adopted probably 95% of their smart meters on RF communication, again on the license-free spectrum. So obviously there are huge, successful deployments across the world, and this discussion about the critical services and moving to spectrum maybe it needs a lot of more introspection, looking at the global case studies. That's what I believe, especially from Cyanconnode, and other RF players who are, obviously coming up with so innovative solutions in this field for the smart metering. One point that I would like to make is, in terms of security, obviously we have 128-bit encryption, and maybe going beyond that. One simple analogy I'd like to draw here is, security works in the OSA layer across multiple layers, right? So if I may be allowed to point out an example like a Swiss cheese model, right? A Swiss cheese is essentially made of several layers of cheese, right? And there could be holes on each layer. But what we are trying to prevent is that each layer may not be aligned with, each hole may not be aligned with the next hole in the different layers. So obviously you may pass through one layer. We have done this actually. You pass through one layer, but you might be stopped at a different layer. So there are obviously decent enough and strong technologies in terms of security that have been implemented there. So that's my opinion on this, right? In terms of using the license-free spectrum. Thanks. Yeah. Sure.
Just switches off again. Okay. Sorry, in just the keeping time in mind, can I just come to Vinod first and say, can we have your opening comments on the issues that we have put on the table?
So let us understand, for any use case, there is one choice of communication technology will not solve the problem. It will be always combination of technologies come together when you're talking about such a large scale deployment across the country. And we have our own set of challenges, right? That is very, very critical. You also need to look at it, there are three important aspects which I try to highlight in this space. One is the longevity of the contract, which is 10 years, right? The systems which are deployed over a period of 10 years or needs to be monitored, governed, and ensured that they're up to date on the security standards and other things, right? So before we say technology, we also need to understand what are the monitoring ecosystem which has been kept around, which is to monitor around for the next 10 years. So
Correct.
that is the first important point. They may be secure today, reliable today, but will they remain like that for next 10 years? And how, who is going to govern that? And today's security standard could be say X, you are meeting today, and how you are evolving the system. So that is one point which I would like to bring upon. The second point which I would like to bring up is the interoperability. Today, many technologies, either RF or any other technologies, are completely working in a siloed fashion, which are not interoperable both downstream and upstream. That is the biggest risk which somebody has to look at it. The ecosystem needs to come together to make it more interoperable. That is the second point which I would like to make when it comes to the choice of technology. The third point is, again, when I come to look at the demographics of India and the kind of challenges which we had in running our ecosystems, is what kind of resources are required to run these private networks independently by different players, and what could be the operational cost. When it comes to cellular, already the billions of customers are connected, that infrastructure is maintained, there is a robust processes which are kept in by the organization. So if your critical service, because I don't see any dispute that people are not calling this as a critical service, everybody accepts that it is a critical service, then how do you make it more reliable, secured, because there are no incidents till date where somebody could intrude through a cellular system and cause a major havoc in the system. And they are upgraded continuously, monitored, right? But to achieve this, I also feel, because when you compare to global countries, in India, when you want to put an IoT SIM in any device, you put it without any validation by a telco or by anybody. That is the biggest problem which somebody needs to solve. Because globally, that is an accepted norm, that if you want to enable a device with the IoT SIM, right, it has to be tested by a telco. Such process is not existing in India, right? So all these things will only help, but at the same time, I also always believe it's a combination of technology should come together to solve a bigger problem, right? So that's how I set it up. And the more important point which I would say is, because the government is looking for a shorter time frame to implement it, the entire cellular network is readily available. And the deployment can be much faster when compared to any other technology, because you solve your meter installation problem and are at the right location. If the communication network is there, you can start off much faster than building an RF mesh or any other network. Means that's what I believe it, because the speed of deployment can be much faster when compared to any other technology. So that's all I would say.
So, sorry, I just want to,
Sorry. Vinod, just a couple of questions to you, and this is also driven by the fact that you happen to be the only TSP on this panel today. So don't take it,
No.
it's not something reflecting on you, but it's more about the domain itself, the other players as well. One of the a couple of big issues that utilities have faced this, and I myself have been implementing AMI over the last 20, 25 years in many countries. And it is the same issue outside as well. The issues are, number one, TSPs don't commit to a 10-year horizon on the same technology. That is number one. Number two, today the business of TSPs, which is based on either voice or large data, is 100 times bigger than what smart metering can get you. And therefore, in many ways, it stops you from going beyond a certain level of investment. And probably that's also a reason that you don't commit to SLAs and agree to only best effort basis. So
Okay.
what would you say on these two elements?
So let us look at our own experience in India here, right? What we have identified with our statistics with 2 million plus smart meters are already implemented. Many times when meter reads don't happen, people blame the cellular company or connectivity is not there. But if you look at it, more than 80 to 90% of the time, the connectivity is not the root cause of it. There are many other reasons and they don't follow the best practices. For example, if you put a meter at a particular location where there is no connectivity at -2, -3 basement, you will always struggle to manage the SLA, right? So what we are recommending as part of our best practices, when you do consumer indexation, look at the signal strength and install it. Two, there are some critical capabilities which are not allowed right now on SMS communicating and other things. So that is something which we are working with the departments to see how we can do it. And the third part is cellulars to some extent are lacking NMS capability to understand the heartbeat and the device availability for communication. That's where we are investing with our partnership with Trilliant to bring in NMS capability.
Sure.
Right? And the other important part is the kind of SIM which is used. People initially started using the normal SIM. The life of the SIM is much lesser and moisture related problems. There are many related problems. So we have come out with the best practices to make cellular as a preferred option and easily achieve the SLA. The problem is the operational parameters are not controlled by us, because of which we say best effort basis. But now today, what we are saying, if we are taking care of the entire ICT, that is information, communication and technology, which means connectivity, HES plus cloud, when a single operator operates, you are addressing the entire problem, and there we are willing to take the commitment of SLAs. Because if you take operation in isolation, that is a challenge.
Okay.
But when you take the holistic responsibility of entire ICT chain, it is a completely different perspective, I would say, right? And the last point on the commitment of technology for 10 years, it is just not the company's prerogative to do it. You understand the government policies are also come into question, whether we can run 4G for 10 years or 20 years. But we see, because the way the voice currently is only running on 4G, and we have seen 2G to 4G, it is 20 plus years now, right?
Right.
So even though technology moves much faster, even you cut it by 50%, so another 10 years 4G should remain. That's how I put it.
Yes, but okay. I mean, I take your point on the club responsibility and that you're willing to take an SLA, which is very good for news for the industry. But I think it is the 10-year life cycle, if I can call it, of the AMI projects. It is a very important decision to address, because look at the first ESL project, 2016. It's not even 5 years and we have had to change over the technology in the meters itself, which is just not sustainable.
Yep.
And we hope this can be resolved. Because there are countries in the world which have not only resolved it, they have actually committed to even 2G and a 4G rollout, and the telecom operators have signed a 15-year deal.
Right.
Up ahead.
Right.
Yeah.
So that has already been done, so it's not new.
One example I can, actually I just got, no, sorry, I'm just
Yeah,
interjecting
please.
here. While I agree with you, right, in terms of there is no one technology that will, obviously work with an entire landscape or an utility project. One example, obviously you pointed about sunset of technology, right? This has happened in UP, my peer from, obviously ESL has been evidence to that. So the challenge is the sunset, obviously, because what happens with 5G, right? Tomorrow you'll have 6G. You need to obviously change the entire infra, and the cost is humongous. I'll tell you one example. Because of our principals in UK, right? They were telling me, this is fact actually, the UK National Smart Meter Program was entirely devoted with, built with 2G, and they had to migrate to 4G. The entire program initially, which was costing about $150 billion, just because of the migration, they had to spend another $5 billion. Just on the we don't know who has taken the cost on their shoulders, but it has happened. So
That is not quite good. We'll let it pass. Okay. Right. Ajay ji, I know we really need your voice here as the representative of the utilities. What you've heard, Fabien talking from the private networks and the cellular networks, and Vinod talking from the shared networks perspective. What do you think are the missing pieces or the challenges from a utilities perspective?
Yeah, right, Kashyap ji. So we have, technology partners here in this panel. So maybe I would not be focusing on that part. But as far as my experience is concerned, in rolling out and operating the AMI systems, so there are two very important things. One is like you do proper survey on the ground so that you identify which technology would be better for a particular area or a geographical location. So that is a must thing. And the survey and all these data collection before the meter installation has to happen through technological tools. So that is also an important aspect, and those tools has to be integrated with the AMI system. And the second part, while maintaining the SLAs, because everything is based on, what kind of SLAs you will be maintaining, irrespective of the earlier perspective where utilities, tries to select the technology on which the particular AMI system would be deployed. Now it is the AMI SP who basically decides based on, his assessment, how he will maintain the SLAs, because everything is, focused on, or I would say all the things depends on his financials, and everything depends on the maintaining the SLAs. So he will try his best to select the technology. And while the first thing would be the data collection, proper data collection, information collection on the field, and the second thing would be how you will be monitoring the status of connected meters and the kind of status of network providers. That is also an important aspect to it. So I heard Vodafone, they are now trying to create NMS and all other things, which is very much necessary in monitoring the status of the network. And while in AMI there are provisions to monitor all these status, kind of in terms of communication status of the meters, but whether at what level all these things are being monitored, and the concept of smart meter operating center, operation center, that is very important to have a broader picture at management level, so that all these things can be properly monitored and corrective actions can be taken timely. While the technology upgradation, it always remains a challenge because when any such things happens on the field, it is very difficult to basically go to all the consumers and do the upgradation. So this particular aspect, I think, need to be looked into while this 10-year kind of projects are being discussed and being awarded. Right? Thank you.
Thank you very much, Ajay. And maybe I can just add one more thing to what you've said about ground surveys. While the ground survey is a very good thing that we must, as implementers of the project, look into and go through, because it tells us what is the best suited technology on the ground. One of the challenges that we are seeing, especially in smaller towns, is the rapid change of landscape, the real estate development, where suddenly new buildings will come up, new developments will come up, and that changes the profile of the communication that was available at the initial ground survey to what is available, let's say, 2 or 3 or 5 years down the road. And therefore, this is not a one-time exercise, unfortunately. In pockets, you may have to actually repeat it over time. Okay.
Maybe I just want to take on that just quickly is indeed a network, can be it cellular or RF based, is actually a living element, and because all the environment is changing. So one aspect we didn't talk too much about is also automation of that network management. And I just want to, to say that we have, and you talked about the potential lack of NMS capability for cellular unless it's managed by the operators themselves. Otherwise, you lack a little bit of that visibility. But indeed, when I take the example of what we've deployed in Taiwan, we don't do site surveys anymore. So to speak. So we run some machine learning algorithm to find where would be the best spot for our DCUs. But once they are deployed, the network is always leaving, and we have a system always collecting the data from those meter, signal strengths, day and night, and seeing trends and seeing changes, and might change the channel assignment. All of that is automated and runs automatically, and might report some strange behavior, or it's monitoring the background noise, because as we discussed, it's unlicensed band, which means unlicensed is shared, so you could have interference. It could also happen in licensed band actually, but you have more in unlicensed band. So the system always needs to keep monitoring its environment and needs to be always adapting to that. And no matter it's a star topology or it's a cellular type of technology or mesh actually, no matter that, it always have to adapt, optimize, and in our case, actually, the ultimate metric we use as what we optimize in the network is how many valid load profiles we get within 15 minutes. That's actually the optimization criteria of the whole wireless network. And we optimize channel assignment, et cetera, based on that outcome, which is really geared toward delivering the SLA to the utility. So yeah, that's one point, and India is probably changing even faster than Taiwan is.
Thank you, Fabien. Amarjeet, can I just come to you first? If you will share with us your opening comments, and please do also specifically address a couple of issues that have been raised by other panelists. One about security, and the other one is about interoperability that was raised by Vinod.
Thanks, Vikas. I think most of the topics have been already touched by panelists. So from my perspective, if you look at this shared and dedicated network, right, it really doesn't matter whether it is shared or dedicated. What matters is what kind of technology being deployed, because eventually it is a wireless medium. And what kind of standards and what kind of technology you are deploying actually boils down to that. Especially in terms of security, we talked about like layered of security. For me, on very high level, there are 3 layers of security: the encryption at the MAC layer, media access layer, then the transport layer security, and then the application layer security. All 3 have its own important roles to play. If you miss one of them, you are leaving a hole in your whole network, right? So really it doesn't matter whether it is, as someone spoke about, Wi-Fi, right? I mean, it doesn't matter if you have unsecured communication over, if you just disable your security over Wi-Fi, it becomes vulnerable. But even in Wi-Fi, you have multiple level security depending on what kind of network you want to set up, personal area network security, or you want an enterprise level security. So it doesn't matter whether you are using what kind of network, all matters what kind of technology, what kind of security levels you are using. Like application layer security, in case of metering, since we are talking about metering, it always boils down to what level of security we are using at the meter, DLMS level of security, because it is secured at the meter and decrypted at the head-end system, right? So it doesn't matter what kind of communication technology you are using. So the application layer security is completely on the DLMS security what we have. But in case of the network, the communication network, the transport layer security is very important. How good security is. It is important to have good encryption level at the media access layer, like we spoke about AES 128. But it is also important to manage those security credentials through the transport layer, like EPTLS or WP, I mean, different security mechanism to manage, maintain and renewing of the security credentials. All those things plays very critical role, without which it doesn't matter what technology you are using, whether it is cellular, Wi-Fi, RF mesh, star network, it doesn't matter actually. So that's on standards and interoperability was one topic which Vikas you wanted. So I have worked on standards for almost more than 15, 17 years now, whether it is IEEE, BIS, IEC. See, it is very important to stick to standards because I'll give you a couple of examples. If we, when we were working on Bluetooth, for example, we didn't have different use cases what we have today. One classic example we saw when we were working on USB, we never knew that one of the largest use case today we have is supplying power, charging your phones or any devices. That use case was not there as part of the first draft or USB standard. Now, so once we have the standards, it evolves. It gives you opportunity to go into different use cases and basically evolve in the whole process to accommodate other applications in futures and things like that. But if it is not a standards, that's the dead end because that's specific to that vendor. Whatever that vendor provides you, that is what you are going to get. There is no evolution. It's everything dependent on the vendor. Other examples, for example, you have Android. Once the Android platform was open, so many applications, so many use cases came. Your Google Map. Google Map was published as an open platform by Google, and then you have so many Zomato and Swiggy, everyone is using Google Map today. So there are use cases which we don't know today. If it is standards, we have a scope of going into different applications and things like that. For me, this smart metering, I always call this 1.0 because what we are doing is we are enabling this, these devices, field devices to talk to the cloud. As the previous session, we spoke about, we are only getting the data. What do we do with the data? What are the use cases? Now that is what I call 2.0, which is yet to come. Now when we have these data, when we have this network, what extra we can do? For example, if I have a smart metering network, can I use the same network to add additional use cases? Can I push the data of a smart gas meter, or water meter, electricity, a street light? Can I use the same network? Can I increase my ROI, right? So if it is not based on standard, the answer to that is no, you can't do. You are at the mercy of the vendor. If the vendor supports that particular use case, you may get that. But if the vendor does not support, sorry, you don't have that opportunity. You don't have that option. Until unless we have the standards, you cannot achieve those future use cases, future deployments, and scalability. That cannot happen. What was the other points? Okay, so future of communication technology, how do we see? That was one of the points we were said. So. As other panelists also said that there is no one hat fits all the heads. So there is no one communication technology which is going to solve all your problem. Every use case is unique. Every geographical region is different. Country like India, we have snow, we have -40, we have 50-degree temperature, we have field, we have desert, we have mountains, everything is there. So we cannot have, some places the population density is so high that even one tower or one DCU may not suffice in that small area. But in some of the areas, you have only a few meters deployed. You cannot put one network, a specific network in that area. So you cannot have one technology deployed across India or across one utility, I would say, or across one geographical region itself. So you are going to have a hybrid communication technology, different communication technology working together is what I see. Not only that, in future, I do see that there are different communication technology working together. It's not like cellular is working separately and RFMS is working separately. Can we have some kind of a network which works at more closer level? So those things are work in progress, and I do see, because I myself is a part of some of the standard development program where we are working on hybrid communication technology. So those are the plan, and those are the roadmaps what I see.
Amarjeet, can you just brief us on what is the status of standardization, both at, let's say, international level and for BIS in India? Because their working group on smart cities, last mile communication has been going on under LITD 28 for some time now.
Yeah, so in LITD 28 or in IEEE, we have, on the cellular side, I don't want to make more comment because everyone is aware of what's going on in terms of 4G, 5G, NB1, NB2, so even in NB-IoT there are multiple versions, and there are a lot of other works going on. So 5G and cellular, different cellular technology work is already in progress. When we talk about the gray area of standardization is actually the RF mesh, where there has not been much standardization. There has been many vendors having their own way of using. The actual problem with the standard when we talk is we do have standard specific to layers. For example, physical layer and MAC layer, the lowest two layers we have from IEEE. But above that, I will have to go to some other standard bodies like 6LoWPAN, I need to get from somewhere else, then the transport layer, then other standard bodies, right? The problem is all the standard comes with multiple options, and every vendor is standard compliant, but they're not interoperable because they tend to use the standard their own way, and everyone is standard compliant. So the problem is we don't have a system level standard which talks about all the layers together, how the layers will work together. And we have attempted to solve that problem by bringing one IEEE standard, IEEE 2857, which basically is for RF mesh. It supports your all the requirements of the critical infrastructure, including metering. It has enterprise level security. It supports ETLS with certificate-based authentication. It has frequency hopping, which means all the devices at any given point of time is running on different channels and keep changing the channels so that no one can hack the network. So those kind of feature and functionality been incorporated. The standard is available for anyone to go and get it from IEEE website and look at it. That standard been adopted in BIS also as one of the Indian national standard as IS 18010-4-1. So that standard is already adopted, and that is a national standard for the Indian ecosystem to take benefit out of it. Currently, I think we are working on creating a compliance for those standards, and also looking at, as I said, we are looking at different communication technology, how we can merge together. At the physical layer, MAC layer, there can be two different technology, but above layer, how we can harmonize and work on the same layer. So that's work is in progress.
Thank you so much, Amarjeet. Swapnadeep, can I come to you now? What are your thoughts on the communication for smart metering and the broader applications possibly beyond that as well?
So I was hearing everything, and I come from a company which has a multi-tiered RF solution, not only on 2.4 but on 5.8. So we have a neighborhood area network, and we have a wide area network RF solutions. And in the previous session, you have heard that we are partnering with Vodafone Idea on the cellular networks. So our thought process is homogeneous solutions will not work, that's for sure. The heterogeneous solution is what is the ask of the need of the market, and heterogeneous solution will be there. That is it. Amarjeet ji was talking about standards. We have standards like IEEE 802.11 standards we have in our in the wide area networks. And for the mesh network, or what we call as the neighborhood area network, that we have is something which can have a backhaul to anything. Our own WAN can be a backhaul to the cellular, can be a backhaul to the optical fiber, anything. So taking your point, Vikas, on this one, the first one which you actually have told that why don't we look beyond the energy meters, like electricity, the electrical lamps, the gas meters, and all these things. Interestingly, we have these solutions. These solutions can be used, but if I go one more step and say, what about the public Wi-Fis or the rural broadband access that we have? All these things, if we try to have those kind of networks, it will be something which is future-proof for the government. It will be future-proof for our existing networks. It is something which may be the long-term benefits getting not only for the DISCOMs, but for all the government departments as a whole would be something which is very good and would be an interesting use case to look at. To talk about having electrical lights and, we have this use case, running use case. We have this in Tenaga National Berhad in Malaysia, where Trilliant has this solution that we have the smart meters and the electrical lights. They are on the same grid in the same neighborhood area network, and we are using that. So this is where I see the future is going. Not only we cannot limit ourselves to only smart meters, smart energy meters, we have to think beyond it. Cellular, yes, I mean, we are very fortunate. India as a country is very fortunate that we have very good cellular coverages. And speaking from the experiences that I have working in Kuala Lumpur, Thailand, and in Southeast Asia, we have a good cellular coverage. We can use, that was what our mindset was while we were partnering with Vodafone on this one. And how do we use this already set up network? How do we take it? Yes, maybe cellular cannot, solve every or reach every part of it. Yeah, we come in over there, we provide our expertise, but cellular is, we are seeing as something which is of, core importance to connectivity. And then we see, beyond that, there are some capabilities which needs to be built in the cellular network, which to make them, ready for the smart metering. NMS is one very good field. NMS, or where we do at the, look at the element, the network element, which is basically here a smart meter. Basically, it's a mobile, but it is not mobile. It's static over here. So that is how it is. We are looking at it. So that's my take on it.
Thank you so much, Swapnadeep. The good thing here is, I think, on the panel today, while we come from our own perspectives and our companies specializing in certain areas, the few things that we all agree on is that to make the program successful, it is important to do ground surveys and decide what combination of technologies to use. There is scope for multiple technologies to be adapted at the same time, and that itself will be a way to stop vendor lock-ins and at the same time give you better results and SLAs. And the other element is everybody's agreed on is that we do need an end-to-end security and interoperability of the systems, because that makes it in many ways future-proof and sustainable in the long run. Can I just request the audience here, if there are any specific questions to any of the panelists here, please.
When we are moving from 4G to 5G, why do we still need 4G fallback to 2G?
Okay. Can I request Vinod to please answer that?
Your question is 4G fallback to 2G, right? It's very simple because we started with 2G and there is a wider coverage across telecom operators which is available in the country. In some places, if 4G is not reachable, the 2G existing network will come into play, because for the smart meters, 2G addresses most of the requirements. It is just a mechanism to provide the coverage to get the data. And there is nothing called 4G fallback. 2G is not a technological requirement. It's just bandwidth utilization.
Fully I understand that, but when we move from 4G to 5G, the technology development is happening. Why we still need to have the 2G? I understand that some of the areas you don't have that. Another thing is, cost point of view, as a smart meter manufacturer, the 4G communication module is cheaper than 4G fallback to 2G. It's
Yes.
50% in fact.
So if you go to the statistics of the country today, more than, I think, 90% or 2G smart devices, 2G enabled smart devices. So if you shut down 2G, all the people need to reinvest on their devices to basically replace those devices into 4G. That is one. And if you really look at it, there are, I think not less than 25 crore subscribers on 2G till date. Okay, so either they should be migrated to 4G or 5G or leave them dry, right? So that's what I said. That's why I see 4G withdrawal is little far-fetched idea that it will go away in next. So it's a government decision. If government says shut down 2G, yes, we shut down 2G, but how do you address 25 crore customers, right? So just we are leveraging what we have.
True, but this is the telecom operators who have to work on this, right?
Yeah.
You can't say that government has to shut down the 2G. You can't wait for that.
No, it is about the people having the 4G devices. They want to migrate to 4G, right? It is, we will be happy if they migrate to 4G. We'll be very happy if they migrate to 4G.
Can I add on this one? Actually, I have been, working with telecom billing, and what is basically is, SS7 signal, the basic voice call, that is very much needed. That is something which runs on 2G services. And SS7, when we come to VoIP or the SDN, the software-driven networks, where we talk about that particular, means direction, slowly we are making the transition, but we need to have a fallback somewhere. Whereas if you go to US 911 calls or 112 call in India that we have, this voice call or something which is there, it has to stay. That is the use, that is the essence of what a mobile network is. Mobile network is for, getting the call done. And that is why the 2G has to be there. And that is where, the government is, or any organization cannot shut down 2G as well. But moving forward, all the IoT devices and all, they are moving towards 4G as such. That's a valid point, basically, because the adapter actually costs half. And okay, obviously someday we will see that we will go over there and then it will cost less to us.
It's a natural transition. I would say it is a natural transition, allow people to transit as we move forward, rather than forcing them.
Can I just add here? I think it is more about the smart metering specifications that need to address this, because if there are areas where 4G is already deployed, why are we investing higher for millions and millions of devices? And that is the question for the people who drafted the national spec to be answering. I don't think it is for a TSP, because look, for a TSP, it's simply a cost benefit issue. I have a customer to service, but then there is also, I can harvest this spectrum for much more gains on the 4G, but there is an investment for it. So it's a simple cost-benefit trade-off for them, but it is the more important thing that we can do in the short run is people working on the spec, the nodal agencies like REC who are maintaining SBD should be saying, why are we incurring this additional cost? And I would urge you to say, please make this a representation to them. And I think many of us will be happy to support you on that. Okay?
I would just add one more comment that I do also believe that deploying right now a smart meter with, for instance, VP-IOT and 2G fallback is actually additional cost that is not needed. So I think I see two options for that, actually, from my perspective. One is actually to use RF technologies when there is no coverage. Two is also that we are coming and trying to provide some tools, including to operators, to be able to fill those gaps in a cost-effective way. So I also want to mention that we are actually promoting a VP-IOT base station, small cell, optimized for deployment like AMI, and we are actually open to working with operators to extend their VP-IOT only coverage in a more cost-effective way, and maybe in a way where actually AMI-SPs will be able to deploy those small cells at their cost, but using the operator spectrum. And I think we also want to see those things moving a little bit, because as of now, indeed, for an operator to extend the coverage of their NB-IoT network is very costly, because they use a macro base station, which are hard to deploy and costly. We are also coming with solutions able to support either LTM or NB-IoT at a smaller scale to potentially cater for that use case as well. So those are two ways where, from our side, we try to provide tools for the customer to do that. But I think deploying 2G fallback as of now is not a really future-proof solution. I would look at other ways to fill that gap. But that's my personal comment.
Thanks, Fabien. We are really out of time now, and I want to thank all my fellow panelists here who've taken out time from their busy schedules to share with us their perspectives, their thoughts, and their experiences. And also a very a real thank you to all of you for staying back and listening to all of us. Thank you.